It's your soft-spoken scientist. Before we jump into problems, we need a quick lesson on what calorimetry actually is and what equations you must know. Then we'll do a full practice session and show all the work, okay? So let's get started. First of all, calorimetry is measuring heat transfer. You'll do this in lab. So, calorimetry is about heat moving from a hotter object to a colder object. Heat doesn't disappear, it's transferred. That's why this lab is really about energy conservation. So you got this weird formula, right? Q equals MCAT. That's how I like to call it. So you got Q, which is heat, and heat is measured in joules, J. You got M for mass, which is measured in grams. You got C, which is the constant, which is specific heat of joules over grams times degrees Celsius. And then you got delta T. When you see this triangle, I just zoomed in to explain this. It means difference in, like the product of subtracting two things from each other. Okay, which is the solution to a subtraction and a difference. So it's when you subtract two things. All right. So, specific heat, okay. So, and then delta T is the change in temperature, final minus initial. If you remember nothing else, remember that delta T is final minus initial. Always, always, always. All right. Again, delta T equals T of F minus Ti. Okay. This part matters on exams. If temperature and then C of water is a constant, which is 4.18, please draw this into memory because sometimes your teacher won't be too nice and give you this. 4.18 joules divided by grams times degrees Celsius. That's the constant for water, the specific heat of water. If temperature increases, delta T is positive, which means heat was absorbed, which means Q is positive. If temperature decreases, delta T is negative, heat was released. Okay, exo. We'll get to that a little later. Exothermic, little hint. And then Q is negative, all right? So, let me say this. Water has a high specific heat, going back to this, which means it takes a lot of energy to change its temperature. That's why water is almost always involved in calorimetry labs. Here's another thing you need to know before we do this. Q lost, what's Q? Let's look back. It's heat. The heat lost plus the heat gained equals 0. When two substances interact, one loses heat, the other gains heat. The total heat change always adds up to 0. Let's check this out on a practice problem. A 50-gram sample of water is heated from 22.5 to 30 degrees Celsius. Calculate the heat absorbed. We know mass. We know specific heat of water. And temperature change. So this is a straight Q equals MCAT problem. Okay, so let's get started. Let's start with delta T. And you may be saying, what the heck is delta? Delta is that triangle. Okay, but you're not going to say triangle T because you sound silly. So 30.0 degrees Celsius. You don't even need to include this if you want to. Okay, minus 22.5 degrees Celsius equals 7.5 degrees Celsius, 1 sig fig after the decimal point. Okay. Q equals M, which is 50.0 grams times 4.18. And the unit for that is joules all over grams times degrees Celsius times delta T of 7.5 degrees Celsius. This unit cancels out. This unit cancels out. Because 7.5 is technically in the numerator. This was in the denominator. Grams will cancel out up here, and then you got one down here. They cancel out. Is joules the correct unit for Q? Dang right it is, right? So the units cancel out properly. So when I put this all in my calculator, I get Q equals 1,567.5 joules, right? So here's the issue. I have to make it not that many sig figs. This is way too much. And I need to make it into 3 sig figs, right? So what I'm going to do is I'm going to say Q equals, and I want to say 1, 2, 3. Pretend the decimal point's right here. I moved it 3 times. So I got 1 point. Well, I actually want 3 sig figs. Yeah, I want 3 sig figs, like I said. So 1.57, because guess what? This 6 gets rounded up because the number after 6 is bigger than 5. It's 5 or greater. It's 7. So you got 1.57 times 1, 2, 3, and back to original, times 10 to the 3rd joules. I hope that made sense. And we're going to have more practice problems coming up. An 85.0 gram sample of water is heated from 85.0 degrees Celsius to 98.0 degrees Celsius. Calculate the heat absorbed. So let's find delta T first. You got 98.0 minus 85.0 equals 13.0 degrees Celsius. Okay, so let's do Q equals M, 85.0 grams, times 4.4, that's a terrible 4, gosh, 4.18 joules, grams, degrees Celsius, right? And then you're going to do 13.0 degrees Celsius. So I'm going to cancel out the grams. I'm going to cancel out degrees Celsius and grams. So then you get Q with joules. Is that the correct unit? Yes, it is, which is 4620 joules. Now, I know that it's positive, so I'm going to say Q equals positive. My decimal point would be right here. It's just invisible. So it'd be, and I want, how many sig figs, you guys? I want 3, right? Yeah, I want 3. So I'm going to move it 3, like 1, 2, 3. So I have 4.62. 1, 2, 3 times 10 to the 3rd joules. So I got my decimal. So this is just a classier way of saying it. Check this out. A 100 gram metal sample at 90 degrees Celsius is placed into 200 grams of water at 22 degrees Celsius. Final temperature is 25 degrees Celsius. Find the metal specific heat. We calculate Q for water first, then use conservation of energy to solve for the metal. So let's do delta T of water. So final minus initial, so we're going to say 25.0 minus 22 degrees Celsius. That's 25 minus 22, 3. So 3.0 degrees Celsius. So the Q of water is 200 grams of, it's literally right there, 200 grams, 200.0 grams times 4.18 J all over grams degrees Celsius times delta T of 3.0 degrees Celsius. So look at this, degrees Celsius cancels out, grams cancels out, and then you're just left with the correct unit of joules. So this would be 2508 joules. Let's do it for metal now. So we have delta T of metal, which is 25.0 degrees Celsius, minus 90 degrees for the metal, okay? Which is negative 65 degrees Celsius. So, we are trying to find the specific heat, also known as C. That's a big word to just say find C, y'all, okay? So we're going to say we have 100 grams of metal right there. So we have 100 grams of metal times C. And then we're going to have negative 65 degrees Celsius equal negative 2508 for Q. So this is your Q, this is your M, this is your C, this is your delta T. I just chose to put the Q on the other side. So when you solve this, you're going to get well, I'll do it with you guys. So you have negative 65 times 100, right? Which would get you like negative 6,500 C equals negative 2508. You're going to divide both sides by negative 6,500. This will cancel out, this will cancel out. And if you notice real quick, you'll see we have grams, degrees Celsius, and you have joules, which is the unit for C. See? So, this is joules all over grams, degrees Celsius. Perfect, right? So I know I'm doing it right. So I'm going to do 2508 divided by 6,500 on my calculator. And I'm going to get C equals 0.386 joules grams of degrees Celsius. You see? Can I show you a hint on that? So, why is one Q positive and the other negative? Because heat flows from hot to cold. I told y'all that in the beginning. One substance gains energy and the other loses it. Simple as that. If two substances end at the same temperature, did they absorb the same heat? No. Heat depends on mass, specific energy, and delta T, not just your final temperature. What happens if mass is left in kilograms instead of grams? Well, that's terrible, right? Because you'll be off by a factor of 1,000 because specific heat uses grams. And you guys already know how much I love this. King Henry died by drinking chocolate milk. If I have 1 kilogram, and remember, base stands for grams. Check this out. 1, 2, 3. I'm just going to add 3 zeros. So I know 1,000 grams equals 1 kilogram. So you'll be off by a factor of 1,000. That makes total sense. If this lab finally made calorimetry make sense, please like this video for me and subscribe. I really could use all the love I can get. I'm new, so I appreciate it. And just know STEM is for everybody, but especially you. You got it.